Welcome to Study Loop.
Okay, so in this question, we want to prove or disprove various ceiling and floor functions or statements. So first up, we have ceiling of floor of x is equal to floor of x. So this is obviously true because the floor of x gives us an integer and the ceiling of an integer just gives us the integer itself. So specifically, we let there exists an n in the integers such that the floor of x is equal to n. The ceiling of floor of x is going to be ceiling of n, which is just n, but this is equal to floor of x. So then we have the statement. Now b, all right, yes, yeah. Floor of 2x is equal to 2 floor of x. So this is not true. If we let x is equal to 0.5, then the left-hand side, we get 2 times by 0.5. Well, this is equal to 2 times 0.5 gives you 1, so floor of 1 gives you 1. The right-hand side is equal to 2 times by floor of 0.5. Floor of 0.5 is just 1, also floor of 0.5 gives you 0, so 2 times 0 gives you 0. So the left-hand side, which doesn't equal to the left-hand side. So therefore, this is not true. Now C, the ceiling of x plus by the ceiling of y minus by ceiling of x plus y is either equal to 0 or 1. So this is true. So to prove that it's true, we'll consider the case when, because these are ceiling functions, there exists an n and m such that n minus 1 is less than x is less than or equal to n, and m minus 1 is less than y less than or equal to m. So the ceiling of x is equal to n because it's bounded by n, and the ceiling of y is also equal to n because it's bounded by n. Then if you add these two inequalities together, you get n plus m minus 1 plus minus 1, so that's minus 2, less than x plus y, which is less than or equal to n plus m. So since these are integers, it follows that m plus 1 minus 2 is less than ceiling of x plus y, less than or equal to n plus m. But we know that n is ceiling of x and m is ceiling of y, so we can substitute all these numbers out. Before we do that, what we know is that this is an integer and this is also an integer. So what you're saying is if we let this be a, we have a minus 2, and this is going to be strictly less than x plus y. So it will be the number, it can be any number that's after it. So we're going to take the one right after it, which is a minus 1. So it's the next integer, which is less than x plus 1. So this is m plus or minus 1, less than or equal to ceiling of x plus y, less than or equal to n plus m. So the logic to this is that instead of taking the exact bound, we'll take the integer that is just 1 above it, and it may be equal to it, just the first integer that's right next to this number right here. And we know that n is ceiling of x, so ceiling of x plus by ceiling of y minus 1 is less than or equal to ceiling of x plus y, less than or equal to ceiling of x plus by ceiling of y. And we have the result required because x plus y, and then if we subtract x minus 1 here, we have 1 here. And then if we do the same thing here, we subtract on this side, we have 0. So we have what we want. D. This is ceiling of x times by y is equal to ceiling of x times by ceiling of y. So this is not true once again, because if we let x be 0.5 and y be 2, we have 0.5 times by 2, or left-hand side. So this is equal to 0.5 times 2 gives you 1, so ceiling of 1 gives you 1. The right-hand side is then ceiling of 0.5 times by ceiling of 2. Ceiling of 0.5 gives you 1. Ceiling of 2 gives you 2. 0 times 2 gives you 0, which is not equal to the left-hand side. Now, finally, we have E, ceiling of x divided by 2 is equal to floor of x plus 1 divided by 2. So this is not true, because if we take x be 2.1, then we have on the left hand side, this is 2.1 divided by 2, which is equal to 2 if you just put it in your calculator. On the right hand side, we have 2.1 plus 1, that gives you 3.1 divided by 2, which is equal to 1, which is not equal to your left hand side. So this is not true.